All right, guys. So in the last video that I had you look at, we were on the second page of that package of notes. The second page was where we started talking about arc length, arc being that part of the circumference, just some part of the circumference. And we looked at examples where I gave you the radius and I gave you the central angle, and you had to figure out the arc length. If I had given you the diameter instead of the radius, then it wouldn't be too complicated. You just have to chop the diameter in two to get the radius length and then use the formula that you had been working with. What I want you to do now is to complete on your own these examples that are still on the second page. And once you've completed those, have a look at these examples. So I'm going to continue on with this video looking at these examples here. So what you notice in these examples, and I talked about this in a previous video, is you're still using the same formula we were looking at in the last video, except now I'm asking you to use it to work backwards. Okay? In this case here, you see in question A, it's asking you to calculate the radius. If you know this arc length and you know this central angle, then that's enough information for you to be able to find the radius. It's just that you'll have to work backwards using some algebra. So let's get started on it. I always say to myself, what is the equation of the formula I'm going to use? I know that for a lot of these, if I'm dealing with arc, I have to remember that arc over circumference is equal to the proportion of the central angle, x degrees, over 360. So I'm going to write it like this. X degrees over 360 is equal to the arc over the circumference. It's one of the big ones that you have to know for this unit. Arc over circumference equals x degrees over 360. So once I have my formula set up, I say to myself, well, what is the information that I have in this problem? Let me plug that in. Here I know the arc length. I've got it here, 82.7 centimeters. And I know the central angle, that's 280. Okay, so let's plug in the things that we know. If I know that the arc length is 82.7, that's what I'm going to put up here. 82.7 is my arc length. And if I know the central angle is 280 degrees, then I can put that right in that spot up there. Okay. So what my next line of work looks like is this, after I put a couple of lines in here. 82.7, that's the arc length, over the circumference is equal to 280 over 360. Now, some of you are already saying, well, sir, now I can either cross multiply, I can do c times 280 equals 360 times 82.7. Or if I want to be a little lazy, I can do the fish method. I can say, well, if I want to find c, then let me start here. 82.7 times 360 divided by 280 gives me c. Just in case it's been a while since you've seen the fish method, remember it looks like this. If I want to know something that's missing here, like c is what I'm missing, I start right opposite the thing that I'm missing. So up here is 82.7. I start from there and I say this times this divided by this will give me that. All right, that's how your fish method works. Okay, so let me write that out. I know that in order to use the fish method, let me just switch up the color here. In order to use the fish method, I'm going to do 82.7 times 360 divided by 280. So to get C, it's 82.7 times 360 divided by 280. That's how the fish method works. Okay, so this is what I've got. All right, let's do the calculation here. I've got 82.7 times 360 and divided by 280. That'll give me circumference, 106.33. Okay, so now I know my circumference is 106.33. Now in this case, the problem is not asking me to find the circumference. You might run into problems that you'll see in the homework where you have to find what the circumference is. But this is asking for a little bit more. It's saying, all right, find the radius. Okay, find the radius. If I know the circumference is 106.33, that helps me to get closer to the radius, but I haven't found the answer yet. So I've got to use another formula here to figure that out, right? If you think to yourself, well, what formula, if I have circumference and I want to find radius, what formula is going to be helpful to me? Well, think to yourself, which formula has both circumference and radius in it? And so you say to yourself, okay, I know that there's that one that goes like this. Circumference equals 2 times pi times the radius, right? That's got the circumference in it, it's got the radius in it. I can use that, right? So since circumference equals 2 times pi times the radius, and I know that the circumference is 106.33, then if I set it up like this, I've got only numbers here. 106.33 is a number, 2 is a number, and pi, remember pi is a number, it's not a variable. So I've just got to solve for r here, okay? And the way I can do that is if I divide both sides by 2 to start, divide both sides by 2, if I divide both sides by 2 here, then these 2's will just cancel out. And let me move this up a little bit so you can see. These 2's will cancel out, and now I'll just have pi times r over here. I've got my equal sign in the middle, which is where I always want it to be. And over here I have 106.33 divided by 2. Once again, my calculator remembers all the decimal places. Even if I'm just writing 106.33 here to show the work I'm doing, I still keep all this information in my calculator. So divide that by 2. Now I've got 53.16. Right, so this is 53.16 here. And if I know that 53.16 equals pi times r, and I want to know just r, I want to isolate r, then I divide both sides by pi here. And that way I'll have just r alone. Like that. So now if I go to my calculator, again I say, calculator, divide that by pi. I'm using the pi button here, I'm not using 3.14. Then that'll give me my answer, 16.92. So my radius here, my final answer, radius is equal to 16.92 centimeters. Let me just make sure that that is indeed the right answer before circling it. 16.92 is good. So now that I've checked, I feel safe in circling the answer that this is my right answer. The radius is 16.92. All right, that's how you use it backwards. You set up your formula, you plug in the numbers that you know. I've got arc, so I put that in the arc spot up here. I've got the central angle, so I put that in the central angle spot. Then I fish methoded to get that the circumference is 106.33. Then I use another formula to figure out if this is the circumference, what is the radius, and that gives me 16.92 centimeters. All right, let's do another one. You may have already understood everything from that time around, but let's breeze through this one just to make sure. So here, I've got an arc length. I've got a central angle. Let me use this formula again. Arc over circumference equals x over 360. Well, that did not work. Oops. Okay. You guys get to watch me get confused with my computer here. All right, let's do it this way. Arc over circumference equals x over 360.